In this video, we're going to be solving non-linear simultaneous equations. That is, solving two equations where one or more of the equations is not a linear equation. How does this impact our solutions or answers? Well, we saw when we did linear simultaneous equations, there was only one possible solution. But when we're solving simultaneous equations with non-linear equations, there may be more than one set of solutions. And we're going to use the substitution method to solve these. So let's look at our first example. So look at this one here where we've got a parabola y equals x squared and a linear function 2x plus y equals 8. Okay, so we're going to substitute. So we're going to substitute 1 into 2. So always give some guidance in what you're doing, explain what you're doing. Sub 1 into 2. So here's equation 2. And I'm going to replace that y. I'm going to replace this guy with x squared, because y equals x squared. So it'll be 2x plus x squared equals 8. Now we've got to go about solving this. What I notice is that there's 3 terms that are going to form a quadratic trinomial. If I leave that on the left hand side, so make it x squared plus 2x minus 8 equals 0, I can now attempt to solve this. Now the good news here is we can factorize this into x plus 4, x minus 2 equals 0. And so I get two values for x. I get x equals -4 and 2. And so hopefully you can see here now, because we've got two x values, there's going to be two y values, which give us our 1 and 2 solutions. So let's have a look at taking our first x value. So we're going to sub x equals -4 into equation 1. When we do that, we get y equals -4 squared, which gives us 16. So one of our solutions is x equals -4 and y equals 16. That's one of them. Now let's look at the second solution. Let's go to the top of the second column here. So we're going to sub x equals 2 into 1, and we're going to get y equals 2 squared, which equals 4. And so therefore our other solution is x equals 2, y equals 4. And therefore our two solutions are x equals -4, y equals 16, and x equals 2, y equals 4. So there's two solutions to that simultaneous equation. All right, let's look at another example. Here we've got xy equals 6 and x plus y equals 5. And considering these two functions, that first one's a hyperbola, the second one's a linear function. So quick review of the hyperbola there. That will look something like this. And we're going to have some linear function that's going to go through. And so we'll probably have 2 points of intersection. So let's call that 1 and 2. Now before we can do any substituting, we need to make x the or y the subject in one of the equations. So let's make y the subject of 2. So when we do that, we get y equals 5 minus x. Okay, so now we're going to call it 2a. We're now going to sub 2a into 1. So it's currently xy equals 6. So instead of that y, we're going to put 5 minus x. It's going to be x, 5 minus x equals 6. Rearranging this, we've got 5x minus x squared equals 6, which we move it all to one side. If we move it all to the right hand side, if we leave 0 over there, we're going to get a positive x squared minus 5x plus 6. Now if we factorise that, we're going to get x minus 3, x minus 2, and so our values for x are, solve this, 3 and 2. So now we're going to sub that back into our original equations to get our answers. Okay, so let's sub x equals 3 into 2a, because that's a nice little y equals that we can see here. It's going to be a nice thing to sub back into. So we're going to get y equals 5 minus 3, which is 2. So y equals 2, and we're going to sub now x equals 2 into 2a as well, and we're going to get y equals 5 minus 2, which is 3. And so the two solutions that I get the solutions x equals 3, y equals 2, and x equals 2, y equals 3. So two solutions for our